Assalamualaikum warahmatullahi wabarakatuh and very good morning. Today I'm not in my office. I'm going to stream at home. Okay, for a while I've been sick for a few days already. So in order to help you guys prepare for your assessment, okay, I'll provide the lab module instructions, lab module answering method that I'm going to introduce today. So continuing from our last chapter, which is the chapter 4 under assembly language. Okay, so let's take a look at this chapter. Then before that, thank you for staying with me again for another week for this computer architecture and organization course. So hopefully you will continue again up until the end of the semester. So for those who already liked and subscribed my channel, thank you very much. For those who haven't, I appreciate if you could subscribe my channel and like a few of my videos. So without further ado, let's continue in our next chapter, assembly language. So on the first task here, okay, I've given you one of the assembly language simulator, okay, that's provided openly in the internet under the GitHub. So if you click on the link, you will open a simulator like this, okay. So this is a simulator of an assembly language, okay. So you can see that here is a simple 8-bit assembler simulator. So if you want to look at this, is on the left is the code. You can edit them, okay, as much as you like. Okay, if you assemble here, assemble the codes, you can see that the assembled code will be inserted into the memory, and when you run it, okay, you can run all at the same time. Okay, if you run them, you can see that this code is producing hello world. Okay. So if you see this one representing RAM, this one representing registers, okay. So this one, okay, this one is representing a lot of the memory usage inside the assembly language simulator. So this is credit to the Marco Schweighauser from 2015 MIT license here. Okay, thank you very much for your construction of this uh, assembly language simulator, so that we'll be using to demonstrate to you how the assembly language works. Okay, so in this assembly language simulator, you can see that here is a code provided to you, okay, code instruction provided to you, what kind of instruction that you can use inside this simulator. Okay, so here inside the simulator you can see that they have like for example the MOV for copy a value. So REG representing register, which register you're going to use, register A, register B, or the addresses of the memory. Okay, this one is to define the variable, and then this one is an addition and subtraction, which you use two addresses, two addresses for address addition and subtraction, and for increment only one addresses. Okay, so for multiplication and division, okay, all of them are using one addresses, means that you need to conduct this multiplication and division based on the code provided here. Okay, so other than that, we have a logical instruction like AND or XOR, okay, shift, okay, compare, jumps, okay, all of them is free for you to utilize, okay, and try them, okay, since the person who developed this assembly simulator allow it to be used for free. Okay, so let's take a look at so our task here. Okay, so using the assembly language simulator, create a codes for the equation below and write your code in the blank space below. Okay, you see that here. Okay, have given you task y equal a plus b divided by c. Okay, this one is basically, okay, if you reset this one, we can see that, okay, all of them, okay, you can remove all of them, and then try your own code. So let's start with A plus B divided by C. So in this case, okay, you can put in any example that you want. MOV A 10, for example. Okay, and then MOV B 5. Okay, MOV C 1. Okay. Okay. Okay, so then, okay, we try to do the equation. Add, you should do according to the equation, you should do the division first, since division is more priority in mathematics comparing to the addition. So first let's divide. Okay, wait. Uh, Okay, so we take a look at the division and multiplication here. So multiplication and division multiplies or divides the A register with a given value. The operation will modify the carry and zero flag. So here in this case, if you have A value, so in this case you need to divide. If you want to divide, we see you need to divide it with the content within A. Okay, so firstly in this case, okay, usually, okay, what you should do is that you move the value within A, like for example right now into D. Okay, so here what happened is that the value 10 in A is going to be in D for a while, and then you move B into A, move B into A. Okay, where the B now will be inside A, which is the B is 5. So and then you divide C. Divide C. Okay, and later on, because you already have the A inside D, you just put in add AC. Okay, so let's take a look at what kind of answer we'll get. Okay, let's try getting the answer. So when you try to get the answer is 6 is wrong. So let's check again. Okay, so now we have A into D, which is 10 going to D, and then B divided, it goes into A divided by C, 5 divided 1, supposed to be 5. And then A added with, oh, it's not C, it's D, supposed to be D, because you have moved A, previous A into D first, and then B into A. So let's run again. So you should get the answer in register A. Oops, we need to assemble first. Okay. Okay. So now, okay, what happened here is that, so you see that this on the right side here is in hexadecimal. Okay, let's start again from the beginning. Okay, so what happened here, okay, in register A has been inserted 10, which is A in hexadecimal, you know, A 0 until 9, and then A is 10, and then B is inserted into 5, 5 is inserted into B, and then 1 is inserted into C, and what happened next is A is being moved to D. Okay, you see that inside D you have A, and then okay, B is moved into A. And what happened here? This 5 here will be moved into A. So inside A now is 5. And then this number inside A will be divided with C, which is 1, and the answer will be 5. And A, finally A will be added with D, okay, which answer will be 15, which is in hexadecimal is F. Okay, so this is a simple code here that you can see, okay, created for this purpose. Okay, so if you look back into the PowerPoint, okay, you can see that, okay, we get the result here. You can just copy and, okay, copy every code here, or you can like for example in my case I like to alternate print screen. Okay, so and then I paste here. Okay, so in this case, let's crop it a little bit. Right click, you can crop them. Okay, and press enter. So inside your top, at the top here, you can see that you can have crop. You can crop it. Okay, so you finish with the first task already. Okay, so you have this one. Next. Okay, so next one, next question. You see that we have y a divided with c plus b. So the c plus b is a priority in this case. So let's take a look back into our code. Okay, so for example, in this case, you have the same a, b, c. So in this case, okay, based on the instruction set inside the codes inside the website here, you can see that you need to do a divided by c plus b. So in this case, we will do c plus b first. So firstly, what you do is should put in add b plus c. Okay, and then add b plus c, sorry, add b c. Okay, now the answer will be in b. Okay, the answer of addition between b and c will be saved inside b, because this is two address in assembly language. We mean that the result will be in b. So and then you just divide a with b. Okay, so let's assemble. Oh no, sorry, not divide a with b, because divide you have only one address, and it will always divide with a. So just assemble it again. So when you assemble, and let's run it step by step. Okay, so firstly what happened is that a inside register a. Next step, and then you have, oh sorry, okay. Okay, so this one, and go back to again. I repeat again. So I put in since the mathematics here require you to do addition, a divide c plus b first. Okay, we will do inside the codes with b plus c. Okay, so here what happened here, b plus c or c plus b, either way is fine. Okay, so b will be added with c, and the answer will be saved in b. Okay, answer will be saved in b. And then after that, a will be divided by b, because a is in register a already. We will divide it automatically with b. So you look at step by step what happened. Okay, in this case, a inside register a, b inside register b, and c is inside register c. Next is you add b with c. So now b, you have 6 as the answer. And then you have divide b. So here a will be divided with b. Okay, so the answer should be around 1 point something, but because the register only stores in a real number, so you have only 1 here. Okay, so this is what limited inside the assembly language, because you can only process a real number. Okay, so once you finish again, okay, just alternate print screen, and then Control V, you'll get it inside here, and you can just crop it. Right click, crop. Okay, inside PowerPoint, you can press the crop button. Okay, put it inside code here. Okay, so finish your second task. Okay, okay. Okay, so once we finish with your second task, okay, so we finished with our second task. Let's move along with the third task. Okay, so here in this case, okay, different way of coding assembly language part 1. Do the coding for the equation below according to the 3 types of the instruction addresses. Okay, so you have 3 instruction addresses here. Okay, 2 instruction address here and 1 instruction address here. Okay, so in this case, okay, because this one is not like the simulator, you just put in anything that you don't need to put in any values. You just write in the equation that you're supposed to do here. Okay, so for 3 addresses, okay, let's start with in the equation. Inside the equation, you need to do the division and multiplication first, so you can do it divide b c. Okay, so means that the answer of division between B and C will be stored in B, and then you can do add A, okay, AB. Okay, means that the answer for B, the division will be added into A, and finally you can do sub A, AD. Okay, so the answer of the division added with A inside A will be subtract with D, and the end answer will be stored inside A. Okay, so you can even put, because I put Y here, you can put Y here. Okay, it's fine, YED. Okay, so this one is just an abstraction of the assembly language, so it's going to be fine if we define it like this, as long as the equation is correct. So for 2 instruction address, okay, so in this case, okay, let's start with divide BBC first. Okay, so here you can put in divide BC because it's the same thing as the third address. Okay, here you divide B with C and the answer will store in B, and then here you have add AB, okay, then sub AD, and finally move IA. So here sub AD means that A is subtracted with D and stored in A, and then if you want to put it in Y, you can put in move YA, means the answer in A move into Y. Okay, now finally the last one is a little bit tricky. Okay, so in this case we use, okay, for example, load means that you have one register, which is the accumulator, only to do the calculation. So you have to start inputting data inside the accumulator. So now you load B inside the accumulator, and then divide C, which is B divided with C, and then you add A divided with added A and sub B, and finally sub D, finally subtract with D, and move. I think in my PowerPoint slide I put it store Y, means that you put the data, the answer inside register Y. The answer inside the accumulator that has been accumulated up until these 4 codes will be stored in the register Y. Okay, end of one topic. So next, okay, same thing here. You need to do it according to the bracket that you have inside the equation. So in this case, it's easy. Okay, for 3 address, add A, B, and then sub C, D. Okay, and then you do it divide C. Okay, and then okay, you can use, okay, like here we have move YA, means you move, okay, you can put it move, okay, you don't have to use move, you can use Y immediately here. Okay, so save one instruction there. Okay, so in next one, okay, you have add AB, sub C and D, and finally divide A C and move Y A. Okay, and last one, okay, it's easy one. Okay, here is load A at B, store A. So here, when you load A inside the accumulator, you add it with B and you store the end of the result within the accumulator back to A. And then you load C sub D, and then you store it back into C. Okay, now you load A again, because the answer of the addition before this, load A, divide C, store Y. Okay, so finish with the task here. Okay, you can see this is all the tasks that you need to do for the assembly language. Okay, so that's all for chapter 4 lab session. Okay, if you have any question, please do send me a text message, or you can comment it in the video session inside, okay, our Google Classroom. Okay, so hopefully this will be benefit to you all in preparing yourself for the assessment later on. Okay, thank you very much for your patience since I was sick for a few days. Okay, I'll see you guys later. Maybe next week after we have our assessment that is due within this week. Okay, so that's all for today. Okay, bye bye. Thank you very much for listening to my videos. Okay, for those who already subscribe and like my button, thank you very much. For those who haven't, I appreciate if you subscribe my video. You get updates later on my other class. Okay, basically this class is for my own online learning session under University of Malaysia Pahang. So if this benefit to you in other places, okay, I really happy to know that. So that's all for today. I see you guys later on. Bye bye. Assalamualaikum.